this video, we're going to be solving an equilibrium problem to find the forces in the links. For this example, we have a 150 kilogram mass which is suspended, and we need to find the forces in the links given in the diagram. So we're going to draw a free body diagram, and we're going to assume that the point O is under tension. So we're going to do all of the arrows for the forces going away from point O. So the first step is we need to calculate the weight. At the moment we have the mass, which is 150 kilos. So we need to multiply this by gravity, which is 9.81 newtons per kilogram. So this will give us that W is equal to 150 times 9.81, which is 1,471.5 newtons. Because the weight is attached to the ceiling by a single link, the only force the ceiling can exert on the weight is a pull along that link. So that pulling force is a tension acting along the line from O to the ceiling. So when we draw the forces at point O, we represent the effect of the weight on the ceiling as the tension in the link OA. The next step is to resolve the forces that we have acting from O to B and C. So the force FOB, we want to resolve this into a horizontal and a vertical force. So we know, because of Z angles, that in this triangle, the angle at the top is going to be 40 degrees. We first resolve that horizontal force. So this horizontal force going across is next to the angle 40 degrees. Because it's next to it, and we know the hypotenuse for this triangle is FOB, we're going to use cosine. And so we're going to get that this side, the adjacent, is going to be FOB cos 40. Next, we want to resolve that vertical force going down. So this is opposite the 40 degrees. Again, the hypotenuse, the longest side for that triangle, is FOB. So we're going to use sine. So the opposite is FOB times sine 40 degrees. Doing the same thing for the FOC. So bringing this down, we can create another triangle where we resolve it into a horizontal and vertical force. We're going to start by resolving that horizontal force first of all. So this arrow that goes across at the top is next to the angle, it's adjacent to the 40 degrees. So because it's the adjacent, it means it's going to be cosine, so it's going to be FOC cos of 40. That vertical force is opposite the 40 degree angle, therefore the opposite is going to be FOC sine of 40. Because this system is at equilibrium, the sum of the forces has to be equal to 0, but also the sum of the horizontal forces has to equal 0, and the sum of the vertical forces has to equal to 0. So this will give us a pair of simultaneous equations we can solve to find the forces FOB and FOC. Starting by taking the sum of the horizontal forces. So by convention, anything going to the left is negative, anything to the right is positive. So because the FOB goes to the left, this means we're going to take minus FOB cos 40. The other force, which is horizontal, is the FOC. So this time it goes to the right, so this one's going to be positive. So we're going to add FOC cos 40. So this gives us that minus FOB cos 40 plus FOC cos 40 is equal to 0. Since cos 40 is a fixed number which is non-zero, we can divide by cos 40, and this will give us that FOB equals FOC. And this is what we'd expect in this situation because of the symmetry of the problem. So we can now take the sum of the vertical forces, so we know these also have to add up to 0. By convention, anything going up is positive, and we take anything going down as negative. So going up, we have our tension from the weight, the 1471.5 newtons. Then going down, we have the vertical component of FOB, which is FOB sine 40, and we have the vertical component FOC, which is FOC sine 40. Therefore, we take 1471.5 minus FOB sine 40 minus FOC sine 40, and this is equal to 0. However, from previous step, we saw that FOB equals FOC, so we can make a substitution replacing FOC with FOB. So doing this, we can combine the two FOBs together and bring it over to the right-hand side. This will give us that 1471.5 is equal to 2 FOB sine 40. To solve for FOB, we're going to divide by the 2 sine 40, and this will give us that FOB is 1144.6 newtons. Since FOB equals FOC, this means that they're both equal to 1144.6 newtons. So we've found all of the forces in the links.